Okay. Oh yeah, we're going live. Do it live. Okay, awesome. Your update is ready to install.
Is Jay bringing food again this time?
No, Jay is not coming, which is why there's no food.
Ah, oh, that makes sense. It's the harbinger.
He is the food guy. Yeah.
If we go drinking afterwards.
Then you'll get food.
Yes, yeah. Because I intentionally skipped eating anything because
Test, test. Hey, it's looking good. All right. Out here. Why did that happen? Failing at computers. Seriously, like, I think it's because I turned the TV off. Oh, you know what? I bet it's not set to mirror. Sorry. Give me like one more minute. I'll fix everything. Okay, we have this done. I'm gonna set displays to mirror. I know there's a thing for displays, but I can't see it. Here? No. Maybe. Do you know where displays is on here?
Display.
Lower right. Oh, there it is. I just couldn't see it. Why did they? Mac has like changed a bunch of things. And then there's got to be a way to just stop mirroring. It was not mirroring though. Oh, all right, whatever.
I think we need just use your window.
Oh, okay. Yep. Then my windows are all here. Did this happen? And now they're gone.
Oh.
Here's what we're gonna do. We're gonna unplug. It's gonna be epic. The TV will just deal with it. All right. All right. We're good. I can see things and you can't, which is what I wanted. All right. Well, thank you for coming. You're at San Diego Python. You're in the right place, hopefully. You know, thank you for bearing with me while I sorted out the issues with the AV, and they were my issues personally. They weren't the AV issues. They were personal issues. Anyway, thank you for coming. I'm David. I'm one of the organizers. Jeremy, one of the other organizers. I want to thank Ansir Cowork. That's where you are. You know, Philon, I don't know if you want to say a thing. You're good. Ansir has been with San Diego Python for a long time. We're back here. Like, they've moved locations since then, but when we sort of first launched this meetup in 2012, we were at Ansir across the street. So it's a long time coming. Anyway, I want to thank Jeremy. I want to thank Diane, my co-organizers, who help wrangle the speakers. I guess you just do everything now with wrangling speakers. So thank you. I'll do a couple announcements. We have a sponsor who's going to give like a brief blurb and stuff like that. Just a couple other announcements. We have a Saturday meetup. I don't know if you're familiar. It's on meetup.com. So if you check meetup, it's virtual. It's Saturday, 10 a.m. It's virtual. It's a little bit different than this meetup. This meetup's more of, we have speakers lined up and stuff like that. The Saturday meetup is more of a bring your laptop, connect up to the meeting, and you know, people are working on projects. Sometimes they're breaking out into breakout rooms. I guess it's on Discord now, I should say. It's on Discord. So there's some people are all in one big room. Some people like break out into smaller rooms on Discord. But it's sort of Saturday, 10 a.m. People get together, work on projects. We have a website. It's sandiegopython.org. It has links to our YouTube channel, where this is live streaming to Discord, which is how you would get to the Saturday meetup. It's got our code of conduct on there. It has a link to give us money, which we were talking about earlier. You give money to San Diego Python through the Python Software Foundation. Not important. You don't have to give us money. But if you do, it's cool. Nobody's given us money since 2014 directly, and that's fine. All right. I did want to talk about some conferences that are coming up, as well as some conferences that just happened. Firstly, upcoming conferences. North Bay Python, Petaluma, California, July 29th to 30th. The talks are due next month. They're due before our next monthly meetup. So by the next monthly meetup, if you didn't get your talk in, you're not speaking at North Bay Python. So that's okay. And but you know, in terms of buying tickets, you got some time. Pi Gotham is October 6th to 7th, New York City and online. I think it's both. I don't think it's just online, but I know it is online. But I think it's both. They're doing a live and an online version. I know we had two things, and I didn't go to either of them since our last monthly meetup, so I wanted to sort of ask people who did go to them to just give a brief word if you want to. I know, Jason, you went to PyCon. Yes. Did anybody go to the HTMX Tailwind workshop that was here?
Yeah.
Yeah. All right. Give a brief. How was PyCon?
Yes, PyCon was great. haven't been. I really, but the conference area was really large. Everyone there was a great keynote by Ed something. I basically went up there. Thank you everyone for coming. You know, basically, rather than recorded. So I actually ran into a lot of people out on top, talking to them, talking to me. Yeah, it just totally recommend it.
Yeah, awesome. I agree with that 100%. You know, you go to a conference for the people, not for the talks. You can go to pivideo.org later and watch all the talks. So, well, you want to give a brief blurb about the HTMX Tailwind thing?
Yeah, I think Mario.
Yeah.
It was a really cool show how to set up Fast API and until was using practice off to do
PyCon, wasn't
PyCon,
it? Yeah, I think it was one of the. It wasn't a sprint. It was a tutorial at PyCon.
process.
Cool. Yeah, that was here. That was on April 1st. Awesome. I'm going to post the link into the chat for the live stream as well, but I'm always looking for speakers for this meetup, the monthly meetup. There's a sign up link. You sign up. You don't have to sign up for the next meetup, although please, please, please do. You know, you can sign up for 2 meetups from now or whatever. We're always looking for talks, all skill levels. You know, you don't have to be an expert in your topic. It's fine. Like 100% survival rate on speakers, but like the meetup is run by speakers. You know, like we need speakers to fill the meetup. So like, and also if you sign up to be a speaker, even if you don't have your talk all lined up, that's a good way to force yourself. Most developers are procrastinators. You will get your talk ready if you have to. So please sign up. Everybody does. Awesome. I'll post the link into the chat for that. I also want to just mention JFrog, who's a sponsor of our meetup. JFrog is a platform for a DevOps platform for continuous releases. For example, if you need an internal PyPI inside your company firewall, like that is one of the things that their product does. Ari from JFrog has a quick slide and announcement, and I'm going to put Ari on, and hopefully I get the TV on and you can see Ari. Oh, I turned the TV off, didn't I? Fail everything. Right. Oh my gosh. And now I lost whatever I had. Did I? Got power on the TV. And hopefully things work. And I'm going to turn this around so that Ari can see all your lovely faces. All right. All right, Ari, I'm turning you around. Oh, move this. Yep. Can you say something again, Ari? I'm going to make sure your audio's coming in. Yep. And of course, your audio's switched back to whatever it was not before. So I'm going to get you sorted out. It'll only take a sec because I know what I'm doing now. Oh, but it's not one of these options. Speakers. Oh, it is. It is one of those options. Okay.
Should I say something?
You can, but give me 15 seconds because I have to switch the input on the live stream as well. But you're good.
You got it.
Oh man, you got the voice going.
You can give me 15 seconds. Nice. Oh, I gotta. I'm gonna full screen you, and then you're good to go.
Awesome.
Somehow full screen. Boy, failing at computering today a little bit. All right.
It's okay. It just takes practice.
Yeah, I know. If I pin him. All right. Hey, that worked pretty well. Okay, Ari, you're good to go.
Awesome. Well, hey, how many people? David, how many people do we have today?
I'd say about 20.
Nice.
25.
Okay.
22 to 25.
Okay, well, we'll be inching our way back up to post or pre-pandemic numbers soon. But you know what? This is great. Hi, everybody. For those I have not met online in the past, my name is Ari Waller, and I am the Community Programs Manager over at JFrog. And we've been really excited to be part of the San Diego Python community as a sponsor. I think we're over 3 years now. It was one of the first groups I sponsored when I had a chance to meet David and discuss the meetup almost when I first started with JFrog. So it was really exciting. After a long career doing something else, I became the meetup event manager for JFrog right before the pandemic. So, that was really comforting starting a new position like that as everything was shutting down. But one of the great things about that time, if you can call it great and a silver lining, was just the amazing meetup organizers that we had a chance to work with, David, Diane, and the team, just making sure that Python content was still available to your community. So very, very, fortunate to have met with David and really want to get there in person very, very soon. San Diego Python is definitely one of the groups that I look forward to visiting anytime I get. And I really appreciate the accommodations that you made tonight. But normally I share a short intro about who we are at JFrog as a DevOps software company where our flagship product Artifactory works seamlessly with PyPy and allows Python developers to deploy software fast and securely. But I'm not going to say that tonight, okay? Instead, one of the things that we're reaching out to the community for this month, it's a little bit of a contest, but it's also there is something in it for us, and I'm going to share what that is. I'm going to share a slide really quick. See if I can share a window. Okay, cool. Hopefully you all can see it on the screen. Tell me if you can see it. Kind of, sort of. Okay. That's okay. Okay, great. So, we have at JFrog, one of the things that we've never forgotten is really our roots as an organization. JFrog was birthed in the community with our first release of JFrog, even before we were a company, with an open source project back in 2006, and our company was founded in 2008. But community feedback is really important to us in understanding where people are, especially as it relates to different topics at different times. So one of my tasks this year was, because JFrog cares so deeply about the community, it's important for us to really, understand where things are. So this is obviously opt-in, and it's totally your choice. But for those who enter this 3-minute survey, by filling out a 3-minute survey, you will be entered in to win our April contest. Now, this contest has been done. It's for all meetups that we've done in April. I will say though that it's not some crazy number where you won't have a chance. I think that anyone that enters tonight has a pretty darn decent chance, probably more than a scratch card. If you were to go pick one up at a convenience store, potentially winning a Nintendo Switch. And at the same time, what it also does is it allows JFrog, it allows us to continue to, bring value from the community to our team. And as a result of that, we get to continue funding and things like that. So it sounds a little PBS what I just said, right? And I'm not gonna offer you a tote bag, but I am gonna say that I'm really looking forward to hopefully coming out soon. The good news for you is you don't have to wait long for this. The drawing will be done first week of May, and we'll be sharing once the winner has accepted the prize. We'll be sharing the winner publicly as well. So I want to thank again David, Diane, Jeremy, and everybody for the amazing things that they're doing in the community, and for all those I didn't mention. And thanks for allowing JFrog to be part of it, David. It really is. It's really special to us. And thanks for keeping things going during there's easier times than others, and you really you and the others really stuck through with the community, and that speaks volumes these days. So thank you. Thanks for the opportunity to be part of this. You absolutely do it because that's the fun part. Please.
Okay, we're gonna have audio again. Okay, cool. So I do have a giveaway for the PyPortal. These are a it's like a Python Circuit Python, or I think it's a MicroPython powered, either MicroPython or Circuit Python. I'm not sure actually, but it's a Circuit Python, and it's a small like LCD display on here, programmable. I have a giveaway. You get to see all the names that I drew because
Nice.
I don't know how to do not mirrored screens.
It's okay. You're good.
Actually, hey, I'm gonna mute you, Ra. Sorry, I don't know what I'm doing. I need to unfull screen this. I'm just failing at computers today. Sorry, everybody. Okay, whew,
No, I
made
can't
it.
hear you now. You're muted with that.
Okay, that's okay. I'll unmute myself, I suppose. Okay, now you should be able to hear me, Ari. Okay, so I have a giveaway. I wrote CircuitPython, so yeah. Anyway, the winner is the first winner, if you're here, is Scott Gustafsson. Are you here? No. All right. The next winner on the list, you had to be here to win. So the next winner is Kristen Martin. Hey. All right. Congratulations. You are the winner. Fun pressure. The fun pressure time comes now. This is where I pressure you a little bit. Like, don't feel too pressured, but I'm going to pressure you a little bit. In the future, after you've played with your CircuitPython for a couple months, a lightning talk on PyPortal. That would be awesome if you would consider such a thing. Awesome. Okay, so now I have to fire up another. So I think we have 3 speakers in person and a remote speaker. I'm going to fire up for the remote speaker, and then
That sounds good, and I will. I'm going to hang up here. It was really great to see everybody. And hey, the first person that gets a brand new JFrog, top frog in a special collectible box. So hold me to that. Let me know when.
I will absolutely let you know. I'm going to fun pressure people until somebody does it.
Awesome.
All
Really
right.
great to see everybody. Thank you again. Bye-bye.
See you later, Ari. All right. Okay. Now I light up the next speaker somehow because Discord is on here. Switching. Okay. I'm making it work. Is it on?
Oh yeah.
Oh, I have to. Oh, I have to ask to join again. Oh, okay. Well, I don't. I guess I do need to be. Oh, okay. You're our first speaker. That's loud. Hold on. Sorry.
You have to mute one of the computers that's giving you feedback.
Oh, I'm going to get out of the room because it's my mic that's picking it up. So,
Okay. Give me a go ahead because I can't hear what's happening in the room. Okay. Yeah, I can hear you. Okay. No, that's okay. That's normal. We're organized one of those in Austin. I know how it is. Can you start? Okay, good. So my name is Jacob Barhak, and I'm a computational disease modeler. I'm a Python enthusiast. I actually started learning Python because of this project. I started doing it for diabetes many years ago at the university, and today I'm independent. I developed something called the reference model for disease progression. The presentation you're seeing, I'll give it to you. I'll show it to you. Here, we'll go to jump to the conclusions. There's a QR code. You can actually go ahead and download it with your QR code. While it's showing, I'll tell you the story of it. So I started about 15 years ago. I started modeling diabetes, and I developed tools, all Python tools to model diseases. Some of them are available openly, some are closed. What you're going to see now is my own, the reference model. This is a model that's built on a set of tools that I've been developing for a long time. And I switched to modeling COVID-19 during the pandemic, when the pandemic started, because the set of tools was almost ready. I had to change them to handle infectious diseases, but the idea remained the same. The reference model is a multi-scale ensemble model. I'm going to talk about those later. Some people heard the word ensemble models from machine learning tools. It's a very simple idea. The idea is that you don't have one model to explain whatever you're seeing. You have multiple models, and you're running them all together, and then you're figuring out how to merge those. So that's the ensemble part. The multi-scale part I'll show you later. The reference model, it has a website. Here's the website. There's a lot of information about it. For 12 years, I've been developing it. So since 2012, it's 11 years now, almost 12. And it has 2 US patents on its name. So basically you can, this is protected technology somehow, but some of it is open, especially some of the basic simulation tools. It's called the micro simulation tool. It uses a lot of computing power. I have a server behind me now, well, in the other room, that's 64 cores that are crunching data for weeks to trying to explain COVID-19. And whatever I'm going to show you is my attempt to explain what's going on. And I've been working with this about 3 years, and it's all the time developing and improving itself. So without much more going into details, I'm going to show you how COVID-19 looks, for how a model looks like. You have states. A person can be no COVID and COVID infected. They can recover or they can die. Notice that there is no error back to reinfection because I'm talking the beginning of the pandemic. I'm modeling here since April 1st, 2020 up until April 22nd, 21 days, 3 weeks. And I'm trying to take data and that was accumulated from multiple sources, and I'm trying to match it in the best possible way to get the best possible explanation within limits. Of course, there are many limits. I won't go into details. If someone wants, they can ask me later. You can see that there's above every error, there are several words: infectious, transmission, response. Those all explain our attempts to explain whatever's going on. Infectiousness, how much virus are you shedding? Transmission, if you have the disease, what's your probability of giving it to someone else? Response is actually behavioral. It's the response of people to the pandemic. How do people behave? How they change their interaction patterns? Recovery is how people recover. And mortality, there are several factors of determining when a person dies, if they die out of the pandemic. There's one more word here. It's called observation, and it's outside. Think about it. All the data that we have about COVID is dirty. We never know whether things are correct or not. So what we're doing is we're correcting this, and there are multiple observation models. Each one of those words that I used before, that I covered before, infectious, transmission, response, observation, and of course mortality, has multiple models for each one of them. So there are multiple infectious models, multiple transmission models, multiple response models. Think about those as assumptions of what people tell you the disease looks like. Think about it as the elephant and the wise man, and each wise man is telling you a different story about how an elephant looks like. And what the reference model does, it tries to merge all of this information in the best way possible. And I'm using some machine learning tools to do this. The data comes from multiple sources. The COVID tracking project is the main source of where data comes from. They recorded information for each day, where it how many positives were they recorded, and how many deaths and hospitalizations, and a lot of data. I mainly would look at the number of positives, and I'll call it infections. But there's also data coming from census data and temperature data, even is from NOAA. But let's look at the models and see how it looks like. By the way, the presentation, if someone is interested, it's made with Holovis technology. This is a static HTML file that I can interact with. So it's like a Word document, but interactive one. And it's basically an HTML file. So you can download it and play around with it. It's static. Check out Holovis for all the Python enthusiasts who wants to see how to do this thing. Let's look at infectiousness. This was a side note because it's a Python meetup after all. But let's look at infectiousness. And I'll tell you why infectiousness is important. If the Department of Homeland Security at the beginning, since the beginning of the pandemic, was releasing periodically, I think every week or so, they were updating it, something called the master question list. It's a document. You can even probably find it now. By the way, you can find the references when you download and actually see where I got my data from. So on May 26, 2020, at that point way into the pandemic, they were asking the following questions. The master question list was very important document. They actually said, this is what we think we know about the pandemic, and this is what we want to know. They said questions and they organized them very well. One of the questions they were asking is, what is the average infectious period during which individuals can transmit the disease? Think about it. In May, end of May, they still didn't know the answer for that. This question later on disappeared because it actually was kind of ill-defined, because infectious is something that happens since the day zero where you get infected. You may have a different chance of transmitting, of generating virus. Infection is how much virus you generate or shed. Something it's called shedding. And here you can see different models can tell you different profiles. Think about it. Also, different people will behave differently. So the question is, what proportion of the population behaves like this? And what proportion behaves like this? Some of the infectious curves are longer, some of them are shorter. And then, of course, there's the average. We'll get there at the end because this is something that I want to compute, and the reference model will help you to compute this. But think about it. We want to be able to answer those questions during the next pandemic, and the sooner the better. Then we can have better abilities to actually cope with it. Transmission models are models that deal with the ability, once you are infected, what's the probability of transmitting to others? And it can depend on many factors. The numbers here may seem low. Let's look at the individual encounter. This is in percent. That's the chance of, if you encounter a person who has COVID, that's your chance of actually getting the disease from them. The first publication I had in Curious, we had 0.6%. It's not very high. It doesn't seem high, but the numbers were a bit low anyway. People, you ask them, sometimes they will think of much higher numbers. But think about it. You meet a lot of people, and you interact with each one of them. If this number was high, then we were all infected. So the numbers that I'm seeing now these days are around 2%. So there are multiple models here. You can see 5 models. Each one is a different percent rate of per individual encounter. But there are other other aspects to transmission. One of them is, do you live in a place that has a high population density where people interact too much? So this will increase the ability. And different models will have different aspects. There's a random constant to account for things that we don't think about. Like, I don't know, someone comes out of state. So change the population. So random constant will change this. And temperature, the virus itself in different states, it was in different temperatures at different times. So there are two models, 2 and 5, that try to compensate for that. And later on, we'll see how effective or not effective it is. So those are 5 assumptions about the chances of transmitting disease. Response models are how people behave. I won't go into details, but it controls the number of interactions the person has. And there are multiple factors there, including what's your size of the family. But the main drivers in the models are usually some level of compliance and where the data came from. So the first 2 models come from Apple mobility data. Apple tried to figure out how many times people click on their maps, and this kind of is an indication of how mobile they are. The more mobile, the more interactions they'll have. And they had data for each day. Very good. So the first 2 models are Apple mobility data with different parameters there, slight differences. Model number 3 represents the portion of the population who ignored COVID. I believe that some of you know people like that who said, okay, I'm carrying on as if there is no COVID. So model number 3 represents those people. Models number 4 and 5, they came from information that was supplied to me by Eric Ferguson. He actually went for all the states and wrote down when did they shut down, what was the level of shutdown, what was whether schools were open, whether bars and restaurants was open, non-essential shops open, and of course masking. All of this information he gathered, and from this we extracted 2 models about behavior of people, how many people to interact with. So those are response models, behavioral models. Mortality models, I'd rather show you. Mortality per age, this is the age of a person, this is the chance of dying, but of course you have to know when the person died, because since the start of a pandemic, you also have a temporal element. So this can be deduced from multiple aspects, but the main model was here that came from the CDC. However, there is one more thing, one more model that came from Filippo Castiglione. And this is what makes the reference model a multi-scale ensemble model. Let me explain the idea of multi-scale. In disease modeling or other types of biological modeling, sometimes there are models, you can do it in different levels, spatial levels. Like you can model the cells, the virus, you can model the molecules, or you can model the human or the population. When you move between those scales, it's called multi-scale model. And this is what Filippo Castiglione did. He actually calculated what's the chance of cells dying in an organ. And then when the organ dies, when enough cells die, then when the organ dies, and then eventually how the human dies. So he actually had a model that shows for each age the probability of dying in a specific day. This is a very good model. You'll see it later. It's kind of becomes dominant. It's very good, and this is part of the ensemble. Remember, the ensemble has many models. We'll later see how influential it is, but before I show you how influential it is, I want to show you the observation models. The numbers reported by the COVID tracking project, as much as they did great work, and they did great work, I cannot state enough. They were like the best data source out there for quite a while, until they shut down because it moved to the government. Actually, Johns Hopkins later took it, I think. But they were the best source of data. But even then, they knew that they had problems. They actually had ratings of how good their data is at the beginning. They would give states grades. So observation models try to correct for this. There are 5 observation models that I'm using here. The first one says, you know what? All the numbers reported are exactly as they are. Don't change anything. This is ground truth. Model number 2 says, you know what? The positive numbers you're getting for infections, now you have to multiply them. Multiply them by 5 to be correct. Because think about an expert that doesn't believe numbers saying that they're underestimated. The third expert, or the third model says, no, not 5. You have to multiply number of infections by 20. Fourth model came from Lucas Butcher. He actually said, that deaths are actually something you have to look at, the number of deaths. You have to change not only the infections multiplier, but you also, per state, you have a different number for a different number for whether the state overestimates death or underestimates death from the numbers recorded by the COVID tracking project. Number 5, I won't go into details, but it's supposed to be the ideal number because I ran a simulation and then I fed back the results. Should be. Is it? We're going to see in the results. So the results were executed over, just to give you an idea of how much computing power, 64-core machine for about 3 weeks. This is equivalent to 3.5 years of computation on a single CPU. In the past, I ran it on the cloud when some institutions gave me, like Rescale, Microsoft, AWS, and later on Midas through NIH. They gave me some cloud computing time. So simulations don't have to go for weeks. You can do them in a few days. Depends on how much computing power you have. It's all highly parallelizable. This is embarrassingly parallel. You run all of these, and by the way, so for those Python enthusiasts, I'm using Dusk to orchestrate all of this. I'm running variations. Each state here, you can see each state in the US, actually 48 of them actually got inside because they had all the data correctly, so I can actually run it. Each one of them is represented by 100,000 individuals. Each simulation is repeated then 10 more times. Excuse me? Someone is speaking, trying to ask something? Okay. So if you have questions, you can interrupt. It's okay. So what you're seeing here now are the results collected from all this data. And what you're seeing here, each circle in this plot represents 1 day. So this is New Jersey at day 21. This is 22nd of April. And you can see there's all sorts of information there. It comes from the states, from the census, from multiple sources. But let's look at 2 numbers, the observed infected and the observed death. I'm going to leave it like that. You can see numbers before the slash and after the slash. Number before the slash is what the model reports. This is what the model computes. The number after the slash is the target number. This is how many people out of 100,000 actually were infected according to the COVID tracking project. And remember, this is the observed infected number. This is the number as reported. Number of infected can be different. We adjust for it. So the height of the circle here, this circle, its height represents the difference between the model and the target. So this is the error. I call it fitness, how well the information fits. And you can see it's way off by about 800. It's approximately, it merges also the number of deaths that you see later. The number of deaths is much smaller, so it has much less influence. But it's about 800, which is not a very good model. So, but you can see other states have different numbers. The numbers also were different in each state. And the height here is the error. Ideally, you want the fitness or the error to be as close as zero as possible. This means everything is dandy. Like we have the best model out there. We'll never get there, but we can get as close as practical. How do we do this? What we do is we take all the models and assign them some sort of level of influence. How influential are they in the ensemble? Think about it as the volume of each model in the choir. Which one is more dominant? And now what we do is we optimize. Here you see the infectious model in blue, transmission models in this purplish color. Green, you have the behavioral model, the response models. The high ones are the mortality models. It's complicated. I'm going to skip details. The observation models are here in purple, in pinkish. What I do is I optimize. Each iteration like this takes about a day or a day or 2 or 3 to compute on my server, or if you have a cloud, a few hours. And little by little, you can see all the circles here drop. Again, what I'm showing you is it's possible to do it interactively due to all of this technology. Up until I get to iteration 9, here in the plot here, you see the overall fitness. You can see all of those plots kind of dropped, and you can see now there's a mixture of models. Some of them became more dominant, some of them less dominant, but they all still participate. It's still like an ensemble. It's still like an orchestra of models. Some of them become more dominant, and because of them becoming more dominant and the others losing some influence, you get a much, much better understanding of what's going on. And this is what the reference model does, tries to explain by figuring out which models are more important and how do you combine them. Remember the question the DHS asked, which what's the average infectiousness model? This is it. At the beginning of the simulation, this is the average, meaning we don't know any better, so we start from averages. But later on, when the mixture of the models changes, it gets to something which is much more accurate. And now we can answer the question that DHS asked. But also we can tell you what was the transmission rate. We can also tell you what the mortality rate, and so on and so forth, or estimate it much better than we could before. Of course, there are limitations and nothing is very accurate. As you can see, there's many inaccuracies, but you can see like the transmission rate is it's higher than the 0.6%. It's more like 2 point something percent. You can actually calculate it actually. You can see that the Apple mobility data is a good estimator. We can actually see that the amount of people that are not adhering to all the rules are very small. This is the people who ignore the pandemic. It's about 11% here. You can see the Castiglione model, the mortality model is good. And one last thing that's surprising, the observation models almost didn't change. This is where I come to the conclusions, and I'll tell you, those things do change, because this is the best I could do with about 2.5 years of work. I'm still working on this to make it even better. What I'm doing now is I'm not calculating what happens from 1st of April, but I'm actually running a window of what happened the 1st of April, what started in the 15th of April. I run the start simulation in different dates, and I'm optimizing all of those together. So basically, I'm adding the temporal element as part of the ensemble. And this is what's happening now. I'm going to just show you how it looks like, much more crowded. I'm even not showing I'm showing you every fifth circle here, and it's still crowded. Simulations look different and numbers look different, but there are some things that seem to be constant, like Castiglione model is still good. By the way, this is a bug. The simulation with the bug in it. I had to redo it, but I'm just showing you how it may look like, and I have the corrected simulation that runs now on my 64-core machine. It will finish sometimes next week, and hopefully it will be stable and we can show some better results. So to conclude, this tool is available already now. It has 2 US patents on it. Many people contributed to it. Look at the acknowledgements. You'll find some many people who helped, some organizations that donated things. I have to give you a conflict of interest statement because, well, I have 2 patents on this. I do expect to profit from this technology. I've been developing it. mostly self-funded for about 15 years now. Actually, self-funded for about 10 years now. So, but the technology is available, and you're welcome to download this presentation and look at details, and you'll find that I gave this presentation multiple times. Last year it was a keynote in Paris. I'm open for questions if you have any, especially about Python tools, because I didn't talk too much about Python. I just gave you highlights. Hello. DHS is only one possible consumer. Think about it. Think about the mayhem that we had in the last pandemic, but not being able to explain it. Most models out there that were trying, there are many, many publications and models of people trying to forecast or say that they can predict what's going to happen in the pandemic. The real truth is we still cannot explain it properly. And this is many years after. If you had a tool that can explain it during when it starts, yes, many governments will be interested, but many other entities will be interested as well. Think about the ability to explain a phenomena, and forget about it. This is not, before this, I was working with clinical trials in diabetes. The ability to explain what we're seeing in things that we can actually, in things that humans can understand, is powerful. And we still don't have enough tools to do that. There's another project I'm doing about that handles clinical data, clinical trial data. The amount of noise and mess with all of those biological data sources is enormous. We have to have better tools to deal with it. And the idea is, I have a cell phone, you have a cell phone. Think about the ability that your cell phone will replace you, will replace a doctor in the future. This is what I'm aiming with. But to get there, we have to go through many, many small hoops. Some of them are ensemble models like I showed you now. Do I make sense? Yeah, so I will correct you. Don't use the word predict, because the word predict the word predict itself is problematic. Think about it. What does it say? Predictate, predict. Use forecast, like forward cast from things we know in the past, we may project in the future. Use project, use estimate. The word predict confuses us all and gives people the impression that we can actually understand things. We still don't understand many of those things. And this tool, the idea is to explain it to at least to ourselves. Later on, machines will understand it. But this is a long process, and I'm only at the very beginning of it. Thank you. Okay, so I'll explain this. Check out something called HoloViz. Just Google HoloViz with a Z at the end. It's mostly developed by Anaconda. This technology allows you to do, I'm using the static capability, but other people are familiar with tools like Plotly or things like this. Think about the ability to build a web page by using only Python. And in all of those things that you did with Matplotlib in the past, you can no longer have to use only Matplotlib. You can use any backend you want. You can use Matplotlib, you can use Plotly, you can use Bokeh. This is Bokeh, for example, as a backend. This allows you to build web pages that later you can kind of freeze. Think about it like pickling all of your data and whatever, and just compressing it into one page. And this is what I did here. The page itself, you can download the HTML, and it will run in your browser even if you disconnect the internet, and it will show you all of those graphs. It's all built in. It does take a lot of data. This file, I think, it's about 30 megabytes in size, but it's compared to the sizes of videos and stuff like this, it's still tiny. But it does load in a browser, and it does show you, and it has all of the information. It's like freezing a document with all the interactions in it. And it does this by some sort of JavaScript, and it includes all the data in the HTML page. You can actually go in the HTML. It looks kind of encrypted if you actually look at the HTML, but all the data is there. And you don't have to do this. You don't have to compress the file. You can actually do this as a web server. It will also work. There's tools for the tool. The tool is called Panel. Holov is a set of tools like HoloViews, Panel, GeoViews. It's a whole world. Check out HoloViz. Highly recommended. It's like 6 a.m. by now, but yeah. Yeah. Thank you. Thanks.
You have audio.
No, all the audio will be coming out of this mouth.
Okay. You're also.
Cool, excellent. All right, I have a very important question for this group. How many people here are fans of Star Wars? Please use a single. All right, good. Nearly everybody. All right, excellent. Gentlemen here, which of these very expensive movies? Oh no, now we do.
That has a spot in even though I know it's
There's nothing
the
wrong with
best
that.
one.
You know, I suspect like the first Star Wars film that you saw as a kid is probably whichever one that was, probably the one that stickiest, right? So for me, Empire Strikes Back used to be my favorite movie, favorite Star Wars movies for the longest time. Still up there, but Rogue One has definitely taken that spot. But fair enough, Phantom One, okay, or Phantom Menace. Okay, so in Phantom Menace, what was one of the key planets in that movie?
Also, there's
Yes, the double suns, twice the sun, twice the fun. Cool, excellent. Okay. So fortunately, there's a lot of Star Wars content out there, and this gentleman who put this map together, Henry Bernberg, sorry, and Dr. Kevin Bierman put together this galaxy map, Star Wars. They basically pieced together all the public content that was out there. Here, that Tatooine is over here, way out in the Outer Rim, as it should be from the world. And Coruscant is the center of the Star Wars game. Okay, so looking at this map a few months ago, and looking at the FAQ, there was this chunk here where the creator of this map had been asked many times, I assume, if they could plot a hyperspace route between systems. And we can see here he apparently has tried this, but he's unable to do this. Either the tooling or the data that he has. So I work for Neo4j, which is a graph database company. And we love networks and graphs, and we can quickly plot shortest points from any two location on a networked graph. So I went about to create a hyperspace plotting app based off primarily on this data, but also on Wikipedia data that's available. Okay, fortunately, the creator of this map put a download section that had a spreadsheet of the systems, but you can see here what's missing here are two things: coordinates and relationships between systems. So, unfortunately, I did reach out to the creator, but he never got back to me. So I'm not sure if he's still maintaining it or he just doesn't want to talk to people with corporate email accounts. I did try twice, once with my personal email to but he busted me out, I guess. So, fortunately, a partner of mine, she's a data scientist. Somehow she found the API somewhere. I still don't know where. And in the Wikipedia data is coordinate data and so yeah. Okay. Okay, so if I just jump to a planet right here. So this planet data within their data set, vectors, grids, coordinates somewhere, at least in the API, the so it's great. With coordinates, I can plot the accurate map of the galaxy. And in here somewhere, there are a list of hyperspace lanes. It was great to know after I had already spent a month looking at this map and creating a doc that showed which system I was connected to what other system, so that I had enough information to put into. Okay, so after putting all this information into our database, I created a really quick stream kind of interface. And unlike Dr. Jacob, instead of HoloViz, which I could not figure out, I did try Plotly and a few other plotting libraries and ended up with Matplotlib, old, reliable workhorse. And just the look of this, just the rest of my teammates were like, oh, so much more like, 1970s. I mean, it's kind of comparable. So ended up going with Matplotlib. So here we've got the scatter plot with XY coordinates and a few of the highlighted shown. So I didn't get a chance to really put in all the hyperspace links, any system. So all the blue planets here are the ones that are connected to that I managed to get into. Okay, so Naboo. Where did they go from Naboo early in Phantom Menace? So like the princess, right? She wanted to appeal to a bunch of folks on which planet? Remember?
On the spot.
All right, sorry. Okay, so I think if I remember right, Phantom Menace, they went from Naboo to Coruscant. Was it? Or was that in the follow-up movie? It wasn't in Phantom Menace. Okay. All right.
No, this is.
Yes.
But we want, or Qui-Gon says, we're taking you to Coruscant. We're taking her to Coruscant.
Yeah.
Droid says, Coruscant, you're under arrest.
Mm.
I remember the line.
So, okay. I'm trying to. Now, I got my order of events in this. So, I mean, Tatooine at some point, Naboo, Coruscant. I'm trying to remember, why were they on Tatooine? Oh, right, to get fixed. And yes. All right, excellent. Okay, putting it all back together. Okay, so we'll go from Naboo to Coruscant, which is actually a long course, because Naboo can see here is very close. It actually be just yeah. So actually, we can plot their course, because so if you're going from Naboo to Coruscant, and they ended up at Tatooine, you would assume Tatooine is on that course plot. Is it? Probably not, just by looking at that map. So this is the shortest plot that Graph Database can find, which looks like it grabs this one hyperspace. And it is 41 hops to Coruscant. And I'm pretty sure Tatooine is nowhere on the... Okay.
But they were looking for it out.
Oh, yeah, that's true. Okay, so let's see. If we look at the map here, how far... So here's Naboo. So let's assume that they could not go to Alui. Was it Alasa, Major, and whatever? Let's say they couldn't go to either one of the systems. I don't know. Maybe just knew it was a bad place to go. So yes, they were. Yes, the Force drew them this direction. Right? Right. Okay, let's just assume that they had to avoid these other systems, because that's what I have. That's an extra feature for avoiding particular systems. So put Alui in there. Ones. This. Okay, let's see if we can basically route them. Okay, so it, still 41 hops. Oh, I guess the shortest path already went around. Okay, so we can bump them to more. So the only way to get to Tatooine is if they're basically yeah. Yes, I think the map I suspect was generated well after. Okay, so now we got this crazy course that is 56 hops. So we added about a dozen more, and still no Tatooine. Okay, so you can see where I'm going with this, right? Where you could still plot a shortest course even around that are part of it. And to do this in Neo4j was fairly straightforward. So this is the cipher query. So actually minus this end. Blow it up. Open it up. Hope everything but the code. All right. Okay. Here, using cipher, kind of a verbose. So cipher is a query language for querying graph database. 4J was open sourced a number of years ago, so other database companies did it. Okay, so here, first statement, I'm just name end system. Then here we've got this wonderful shorthand convenient function called shortest path. In the shortest path, I'm just pattern. So in the database, I actually have more information. I have characters, I have all interconnected. Graph database, if I just said start whatever to end, it would give me the shortest path between two systems, which is likely not through multiple systems. It would probably be through Naboo and Coruscant, through Phantom Menace. That would be the short. Here, I'm specifying, okay, only consider connected to relationships because not every system is on a hyper connected to. Planets that are close to a hyperspace. So give me a path. I'm specifying just max number. and then return me that path. That path gives me a list of JSON objects, gives me the information. The second line is just to the system. That powers pretty much this entire app. I'm just displaying the data from that call into here. I'm putting it into a plot, Matplotlib, and here I'm just taking a count. Here I'm putting into a table, all from. So this is all I want to go. Thank you. Oh. Good. Got a question? Our search? So. Oh, wait, is this a reference to the old phone number thing where you're calling? No, okay. Oh, okay. Is it? Okay. Yeah, so under the hood, I'm not sure what they decided to go with. So the shortest path inside Cypher, I think one of several different. So we do have a graph database package, which is like graph data science algorithms, and it gives you like 61 algorithms. So you could choose like a specific algorithm to do all sorts of clustering, page ranking, etc. Here, I was just wanting to stick to Cypher, have that one call. Under the hood, I don't know what it's calling. I should. Yes. So Coruscant is considered 0, 0 in Star Wars Galaxy. So 0, 0. So it kind of does. So we do have information for like actual parsecs and then time to travel depending on StarCraft. We haven't put that all into this database yet, but that's something we want to do next is not only allow you to find shortest hops, but shortest time, safest. Right? There's also data in real leaning planets and low leaning planets. So like, okay, if you want to plot a safe route, if you want to be a smuggler, there's all sorts of stuff that we can just add to the database. That's something I should. Here's the existing data model. Okay, so a little cleanup. We did it was definitely conference-driven development. So we have some errand data like planet MH. But basically, this data says what we use demo at PyCon. So for just the hyperspace navigator, it's just a single node with two relationships. During the presentation, we did connect this to all the developers that were in the room. So we had everyone join a Rebel developer network to help build this navigation app. So we had people, and we had what their skills were, and what characters, friends, and what their affinity was to either rebels or Imperials. So we had a whole another app that was. So here, I had another app that basically would rank all the developers based on this route. Again, not using actual data, but just off a rule. It would score all the developers and give us basically the top 3 devs that hire part of this crack team. So again, that was all powered by the same database. Here, system for their location, but we just added topics. So, yes. Rick. Well, our understanding, which is limited, of the Star Wars hyperspace system was that you would have to hop between. But you're right. In Star Wars, you can go from like one planet. And from what we read, yes, you can do this too, but you have to know what the safest route. So if you were to do the hops, that's the safest route. If you were to jump from Coruscant all the way to Tatooine, then there might be a route that you know that's safer, but not marked smugglers safe route. That yes. Ah, okay. So I can answer the first question. So 2035 planets. Question of what makes Neo4j like, what's their magic sauce, I guess?
Yeah.
So, okay. So my understanding of the underlying technology is unfortunately limited, which is a little odd for being one of their developer advocates. But more or less, the relationship data here, this is stored with all other data, like you would find in an SQL. So in an SQL database, generally the nodes and the relationships are usually generated at. Now you could have a lookup table in between, which is kind of what the are. So the way the data is stored under the hood, got basically kind of a record of nodes, record of properties, record of relationship. Relationship, they contain basically pointers where the node. So when you start, so when we had that query, once you tell the database which node you want to start with, everything after runs very quickly. Once you have that, find the relationship. Because the pointer's already there. The system's able to traverse that network right from versus trying to scan your entire database, find it. So it's not, it's similar to indexing, and you can do indexing and constraints to speed up. But you can do all this without having to set that up. So that's my simplified. Cool. We good? All right.
Thank you.
Thank you.
Traveling through hyperspace.
That's-
Without precise calculations, you might fly car. All right. I know. I didn't actually look that up. True story. I just knew that off the top of my head. Awesome. Our next speaker is Don. Don Guernsey is going to talk to us about text search in Postgres. Jeremy, can I push your talk to the next meetup again? Because it's 8:15 and I don't want to go too late. All right. You're up. I mean, you do need a dongle, and you brought one. Here you go. Hopefully the magic just.
Did it?
Magic is happening. The magic is happening.
All right. So we're way in the. Hold on a second. Ah,
Pretty good.
you guys actually see that? Oh, cool. Now I gotta get back to the first part of it. What the hell? All right, here we go. So my talk is about why should you use TS vector fields in every single project you use. Does anybody here besides me know what a TS vector field is in Postgres? You probably do back there. So what a TS vector field does is it makes your search so much easier. And you guys have all heard about CRUD, right? Well, I don't use CRUD, I use CRUDs. There's a search at the end of it, because if you're entering data, what is the web for? It's the search. So I actually follow CRUDs. So this is the S part of the CRUDs. Now you can go to, these are some of the sites I'm doing right now. Cosmotur is, I'm doing NIST 800, it's going to be a cybersecurity thing. I'm downloading all of the federal data now and I'm shoving it into the database. Beyond Waves has a lot of the San Diego open source database. And it's for my wife, she sells real estate, so I'm trying to give her like a little thing that, you know, people can search about San Diego. Onyx Electronics, I'm doing an auction, you'll see that there. LC Recorder is if you going to record your mortgage, or if you're going to record a document, that's where you search on to see that document that's been recorded. So if you bought a house, anybody here bought a house, they have a mortgage that they recorded and a deed they recorded. I write software that does that. If that makes any sense whatsoever. So one of the things I follow is called PrEP. And if you guys are in a jam or something, and you want to put a presentation together pretty quickly, use prep. It's point, reason, example, point. You tell them what you want to tell them. You tell them the reason you're telling them. You give them an example of it, and then you restate the point. So it's prep. So I wanted to give everybody sort of like a little prep. So it's something you can take and make a presentation pretty quickly. This one doesn't use a ton of it because it's more of a how-to. All right, so my point is using Postgres TS vector fields for a text search is great. You don't really need to go on to Elasticsearch. You don't really need to do all these other things. Text search in Postgres is good enough. It actually is really good. The reason that I use it searches fast, and it uses lexems. Let's say your name was Sandy, S-A-N-D-Y. It's going to put sand in the database. And so if you look up Sandy with an I, Sandy with an E, Sandy with a whatever, you can actually get it because it's a lexem. You guys can go to Cosmoturn and search cyber. You'll see the thing in action. Now that's for a project search, and you'll see the difference. Caveat in this, I'm not doing anything with ranking because they'll take forever. All right, so my implementation on every website I do gives you complete search capabilities based on project search with the whole project. I use Django. I don't know if I said that, but I use Django for everything. So Django, I have a project search, and I also have an application search. Anybody know why I have two different searches? Result set sizes. So if you do a project search, you're going to get, I've had databases that are 400 million records. If you try to do a search on that, you got to be really careful. So, and it actually works with 400 million records. You can actually use lexems, and it'll be fast. Application. So in cyber, I have something called NIST, which is the NIST standards, National Institute, whatever standards. So if you only want to search NIST standards, you just search in that application. And if you go on Cosmoturn, you'll see education and NIST, and you can actually. So here and then here, you can see them both. I put. You guys see these or no? Okay. And then I create a search model in utilities. I call it utils, and that's sort of where I throw everything. It's just sort of my bag of stuff. So, and then I also create a search model in every single application. So I have tons of search everywhere. But it provides complete search capability, and it's good enough. Now, I can also, in certain respects, in certain instances, I'll have field search. So like if you want, one of the things they search on one of my sites is assessed value. If you want to know the assessed value, you can do a to and from. You can't really do that very easily in a vector search, but you can do it with just a greater than and less than search with two variables. So some of the stuff like dates is not real good with vector search. All right, so I wanted to give like, as I go through the code, I wanted to give like the different processes. So like with fixtures and imports, I'll load database data. Fixtures, does anybody know why I'd use fixtures instead of imports? Fixtures makes it portable. So if I write all the stuff in a fixture and I populate a database, I can go to the next server after I just broke this one, and I just run that script again. And I have a script that he won't like, but I have a script that's 21,000 lines. But all it does is load a database. So it runs once and then it's done. And then even make matters worse, I use I use dynamic variables. So I use, you're never supposed to do that, but I do it anyway. So I'll show you like fixtures and imports and you load a database, and app search and project search. I'll show you how it does that. Then there's a manual create and edit. So same thing. Now the request, how do I get there? I mean, sort of like, okay, I got this. Now how do I get there? So the HTML search page, which will be the front page if you go to any of my sites, that's the HTML search page. Now what it does is it sends a request to search the database, which is obviously the views, and it searches the lexems in the database, and it returns a response, which will have a template associated with it. That's how Django works. Now I have some intermediate steps, and I didn't actually probably should have called them miscellaneous. Intermediate probably is wrong. But each model has a .ts vector field. So I just call it the TS vector. And I do that through a base model in my utils app. And inherit that in every one of my models. So I use an abstract model. You guys are familiar with that? Or you guys ask questions as I'm going, because I don't know. You guys probably know more than me, or I mean, I just know what I know. I don't know if it's a lot. So I use the TS vector field is created in a base abstract model, utils app. Okay. Subsequently, I use the base model in every app model. So I know that I'm going to have a created, modified, created by, modified by. I'm going to have the name. I'm going to have a unique name. I'm going to have the description. So I'm going to have a base set of fields so I can write something once and have it be reproduced in every app. I'm trying to make it, trying to do dry. And I'm trying to do dry with also decoupling the apps. So to feed it, I use the self getters, and I'll show those in the subsequent slide. So what I do is I get normally what they want you to do, and everything I've read, they want you to create a script trigger in Postgres to populate the TS vector field. I don't do that. Why? Portability. I've broken too many servers. I want to keep everything so I can just drag over that little folder of all my little Django stuff, and it just works. So I get the 20,000 line. So paginate is a class I wrote because I don't like Django's. Or mine I understand, mine I understand, so I just did. Now the Django dance, if you guys aren't familiar with it, is the URLs file. It has like, that's where you say like, hey, load this, do this. Okay. Then it goes to the view. So the URL says, hey, I need to go here and do something. The view says, well, I'm doing something. And then it gives you the response to the template. Now it's actually model view template. So it should be model view controller, but they sort of bastardized it. All right, so what does it look like? What am I getting? What am I looking like? So this is actually from one of my databases. This is, I think it's a control family from NIST. This will give you that. Now it's lexem and ranking, so you see like -3s in there because there's something in here that was a -3 for the name. Also, if you see it like applet, so it's ranked 3 times. I don't want to get into the rankings because I was trying to make this 7 minutes. This is like speed dial. All right, so here's my search. See the base model? The search, I always want to know who did it. For some reason, I always want to know who put stuff in there, just so I can go, hey, why'd you do that? I have the app label, which are you guys familiar with Django? All right, so everything's an app, and inside the app you have models, which are basically tables. So you have an app and you have a model. Then I have these 2 things called display model, display description, so I can make them look differently. So when I return a result, and I have these things I call strips, it's just a table, HTML table for basically a better word, but it has the same fields on each different model. And so I just throw the strip in there. You'll see that. And then object ID, obviously, if you guys are familiar with the content types, yes, no, a lot of confusion. All right, don't worry about the content types, but you need that stuff. So I make this a unique value. I index it. I probably don't need a text field. App model ID is the uniqueness. That's sort of like my primary key. And then if you notice, TS vector is in there. Hey, where the hell did that come from? Go to the next slide. So here's my base model. So I've created, modified, created by, modified, the name, unique. So I have all these things if I need them, and I know this is duplicated. The description, meta description, and tags if you want to put hashtags on there later. That's a different discussion. TS vectors. So that's an abstract model. That's the key thing right here. Abstract equals true. Now, every single one of my models and every single app inherits this base model, and I know the decoupling's bad. I don't care. Yes. Yeah, an abstract model. You always want to use abstract, like for simple stuff like created, modified, because you want it in every table. Because sooner or later, you're going to go, when did I make? A lot of people just put modified. Don't. Put created and modified. Because you'll go in there, and well, it was modified yesterday, but when did that guy put that in there? Was it the modified data or was it something else? So these are my getters. So here's how my TS vector is formulated. So I know framework cores, that's what NIST calls this. That's why it says that. But so I use the get name, I use that getter, I use the description. I put this because that's the the table it is. So if you want to do on my search, you want to do cyber, and then space NIST, it'll just give you those data points, right? Because this is going to get fed into the TS vector. Makes sense? I see a lot of blank stares. Should I keep going or explain more? Sure. Postgres. Yeah.
Looks like
Lexems, yeah. Well, that's the way I populate it. It's whatever you want to be, but it's a type of field, and it is. Yeah, I'll show you how to populate it. Yeah, right. That's exactly true.
and so it's the
Yes. I have no idea. Text search, yeah, probably. It's Postgres. They call it TS vector, so I'm like, okay, I'll go with it. Yep. Right. Yeah. This is in every model. These three things, and then the string things in there too. You know, the underscore string. Well, you have to populate it. Yes. Yeah. It's if you're not using it, use it. Go ahead. Lexems. I'm not sure how to say it either. Yeah. It sounds. It doesn't care about the ending. Yeah. But, yeah. Right. Trigrams I've used before, but you want to get a lot of results. There's like the happy dance in search. You know, do I want too much? Not enough. Just I don't know. All right. So yes. So there's two different ways. There's a create and edit. That's what's here. So if you look, I did the loading data from the earlier slide. Manual create or edit. So I have a model finish for every model. I left out the logger, but so the finish, it says set. Actually, I left that in there because those are actually should be below there, but I didn't. So it says update app label model. That's how Django creates its tables. App label underscore model. That's how it actually creates its tables. So if you go look in Postgres, you'll see the tables are app label model. Now, if you have a model with multiple names, it's all one word and it's all lowercase. So that can get. What I do is I update. And this is how you set the TS vector, the question you were asking. So to TS vector, you want it in English. You're going to coalesce model vector. If you get nothing, if you don't have anything, you set it to nothing. And then where the ID is equal to the ID of the primary key. And then I execute this thing. Yeah. And then I have a show in every app I use. So the app labels, so it'll say NIST, show, model, ID. So I have a show in every single app. So this is a class I created. It just sits off by itself. Now, wow, look at this thing. You guys like SQL? This is right up your alley. Can you guys see this? All right, so this is how you load on fixtures and imports. No or yes? No? I use raw SQL to input this stuff into TS vector field because it's faster. I probably don't need to, but I got used to doing it that way. You know, the coalesce stuff, it's just easier. So what I do is I put the stuff in there if it's on a conflict with this. Remember this from earlier? That's the app model ID. That's my primary key. So if it's on conflict with that, then you upset the TS vector. So if it's create or edit, right? So if you're editing something, you don't want to override it. I mean, you do want to override it. So this covers the edit portion. Now, if you notice, this goes into util search, right? So this goes into the app search, and this goes into the app search. Put those. So util search is the main search that I start with and I use. That's the project search. That's the big result sets. And then the app search is the search model inside of each application, if that makes sense. So then this basically executes the things I wrote in the last thing, just execute, it's going to execute it and it's going to show these are the data. Remember the get name thing on every model? Get name thing is what I use to get it. Get name and app model ID. So I created all those things and then I closed the connection. Now, how do I search the darn thing? So this is the searching data. This is the request. This is in the views. So I default to a page equal to 1 because if we have results set of 18,000, we only want the first page on the first go around. So I'm almost done. So, okay, so here I go through and I do a regex. So I get words, letters, and the dash. So that's that. Then what I do is I create a list of words by splitting them all up. You have to put this in between when you're searching a TS vector field, because if you don't, it's going to search for both words and they'll never be there. So you have to put this in between. This is a list where I construct it, and then if it's the last item, I don't put, the last thing, I don't put the last one there. I'm in speed mode right now. Then it actually goes and does the search. So if you see here, it only searches the first 200 or whatever the page is. And the pages are like those 1, 2, 3, 4, 5 with the chevrons. And then I do the count, just to execute the count. I use ID. I don't know why I don't use the star, but and then this is the template, and then this is the query, and then this is the paginate that I wrote. So it calls that class, and it gives me the tuples that I like. Don't get anything, it's no query, but here's everything that gets set to the template. So these are all the variables I have when it goes to the template. So here's my paginate class. So I probably won't really go over this, but it just does pagination. And it gives me extra links, so I can control the number of extra links. So if I want 10 in one app, I put a 10 on the last page, and it'll give me 10 numbers. Now the Django dance starts here, so local search result. So this is the search, and it's an intermediate step also, but this is where everything starts with Django's the URLs. This is actually the front page of Cypress Cosmeter. And so, you search terms, so ST, so I send the search terms, I hit the submit button. Now these are the paging. This is my pagination. So I have the first page, last page. So I have like this, and then the 2, and then some pages in the middle. And then I told you about the strips. The strips, I have you'll see it if you do a search on Cosmeter. It has model or app model and then view, so you can click on it. And that's my speed thing. How long was that? Whew, paid off.
Thank you. I had a question actually. I saw it was great. I missed the actual interface. So is it a raw SQL query when you need to query the TS vector field?
Yeah. Yeah, I'll show you in action real quick.
I think I saw it, but I
So I was going quick. So if you enter cyber here, like I put in the instructions, pretty quick, you'll see where everything is. And you see here's the location. I call it location, but that's actually it. So the app is nits, and it's an ability. And if you want to view it, you can click and it'll view. Right, so you have work roles, tasks, knowledge description, skills, and abilities. And the work roles these are a lot of many-to-manys. So a work role can have a lot of skills. A work role can have a lot of abilities. An ability can have a lot of work roles. So tons of many-to-manys. Yeah, page loading. It's DMX, not MX. No, that's what I'm telling you. Elections are, I mean, they're fast. I mean, it's brutally fast. I mean, it's.
Search.
Right here.
But here's format. Here's formatted for you. But the actual data that search. That like.
It's a dictionary.
You have a hit.
No, it's just searching the TS vector field. Yeah, I'm returning the whole row. Yeah.
With records. So
I don't do a multi-field search. What I do is I take all the multi-fields and I throw them in the Lexum. So every single one of them. Yeah. Oh, JavaScript.
So on top. Search term.
Don't tell anybody.
This is what I'm trying to get.
Yeah, no, I use JavaScript. No, I figured I'd just load it, give them something, and then the JavaScript works pretty fast at the end of it. I hate JavaScript, but it does work. So.
Is there any out of the box?
Not that complex, you know. It's
I think there are some libraries to help.
Yeah, that's like why you provide it.
because I'm an idiot. I don't know. Like if you want to do like I was talking about assess value. So I have like the manual search too. It'll search and it'll. I mean, the stuff is zippy. I mean, it's fast.
Looks very fast.
And if you want to, I have a bunch of links. So these people are buying property. I give them a bunch of links to go, look at everything. They have a database?
Sorry.
I don't use. I'm going to show you something. I'll show you if I can find it. That's my 20,000 line. That's my 21,000 line fixture.
I think he downloaded.
No, there's no CSV. I downloaded a PDF.
Downloaded a PDF and it's just a database.
There's no. I couldn't find CSV files or anything anywhere with it. I mean, yeah, probably. I probably could have done it differently. Yeah, yeah. I mean, well, where do I start searching? I mean, I'm searching probably 300,000 records. Where do I start at the third letter, the fourth letter? I mean, yes, you're right. I don't know. I'm not perfect. Oh, you're welcome. This is the 20,000.
Python, favor say aye.
Aye.
All opposed say I'll give a talk next month. All right.
You're up, Jeremy.
Guys have it.
Jeremy's gonna
I
talk.
would give it up for
His
anybody.
Do you
talk has been
need-
very
need- oh,
abbreviated. Sorry.
Yeah. Minutes. Okay. Yeah. Right. Right. So, how many of you know about singletons? Anybody? Somewhat? Okay. Some of you. This is where I would like to bring you back. I've got a computer science education from back in the day. Let's see. So, we were familiar with this book. It's called Design Patterns. This book is out of date. It's terrible. Let's see. Or there's a lot of the paradigms that are not worth, have been worked out in Python. One of them is a singleton pattern. So, let's see. If you have a configuration in a program, let's say I'm going to create a class called config. I'm going to have some variables in here, maybe some methods to do some changing. But throughout my application, I might have multiple files, and I use this particular configuration, and it changes things. Whenever it goes into one part of my file, another part of my file, we want to make sure not to have copies around. So what I end up doing is this. Creating an object called CFG. It is inside the configuration, treated as a library. So in my use configuration, that way all I have to do is import that particular one object. I'm going to create one copy. I'm going to use this same thing in this other configuration file. And so we're going to remember. All right, so I have the print statements showing the ID where it's located in memory. Okay, so I'm going to highlight this one and do a find. Right, so these are highlighted, they're all the same. So in this, I'm going to run the other configuration. Okay, well. Oh, well, this is a live demo, so it's really hard to fake. Anyway, I didn't say impossible, just that's more preparation than I wanted to do. All right, so run the other configuration. So I've got a configuration that does do a change on that particular dictionary, or sorry, the instance of the variable. So, and then I rerun the configuration, and you notice that it's still highlighted, so it's still the same number, still part of my find operation editor. Anyway, I still see senior programmers or people who should know better. No, let's see. People who come out from other languages and start up projects. Let's see. This one's a well-known one where they have configuration and they use a meta class to be able to control this thing. And it's not, it doesn't have to be this hard. This creates some problems. You have to have hacks to be able to do testing on singleton objects in your testing. It's a mess. So this is a very popular application. It's called AutoGPT. And it happens with even the most recent of projects. This is not an old project. Let's see. Anyway, don't give yourself a headache. Let's try to use words effectively and create single. create the instance, the same place you create the class. Maybe if you want to, you can get creative with file names with underscores and that. No need.
Or you can call it.
That's what I always do.
I don't know. I haven't tried that one. I suppose.
Thank you. That wraps it up. I just want to thank our speakers. I want to thank Ansir Cowork for having us. I want to thank JFrog for the giveaway. By the way, if you still want to sign up, I can't remember what they're giving away on top of the Pi portal. Was it a Nintendo Switch? Anyway, the link is jfrog.co/April survey, and A and S are capitalized. I put the link in the chat. You can check it. But usually with these JFrog giveaways, you have to take an action on the day of the meetup. So take the action if you are interested. Anyway, that wraps things up. If you're interested in, some of us will probably walk down to O'Brien's. They have food and drinks. If you are interested in that kind of a thing, no pressure. Otherwise, thank you for coming, and hopefully we'll see you. Oh, I should also mention, next month might be at Qualcomm. Stay tuned to the meetup group. So the location might change. Working on it. Thank you. Sorry.
No. I was like, I can put it down to.
You did great. Thank you.
Want to roll the chairs over
Yeah, I'm gonna stop the live stream. Stream.
That was awesome. Thank you for being the unfortunate idiot.